Good morning, good afternoon, good evening, good night. Whenever you're watching this, good something. We're going to do lesson 16. If you haven't already, hit pause on this and get out your binder. Open up to lesson 16. When you're ready to rock, hit unpause. We're going to practice more with equations. And yesterday, or when you watched the last video, depending on when you did that, we talked about solving equations. And when you solve equations, if it's an addition or subtraction equation, you add the inverse. I guess if it's an addition equation, you add the inverse. If it's a subtraction problem, you add. If it's an addition problem, you subtract. But if it's a multiplying problem, you multiply by the multiplicative inverse, which is essentially just dividing by that number. And we'll look at some of those today again. So here we go. First off, let's look at this warm-up problem. Is the solution positive or negative? A is pretty straightforward. I see a negative 8.7 times a 1.4. Those two parentheses, that means it's a multiplication problem. I see a negative times a positive. So that means that this problem is definitely a negative. Now, in the next one, I see a negative times something, a negative 8.7 times something, and I get a positive. And I do know that a negative times a negative should be a positive. So I don't know, I don't even need to know. I just know that B needs to be negative. On letter C, I got a negative 8.7. I'll write that. That should be negative. We don't have to write that. I see a negative 8.7. I need to add something to it so that I get it at a negative 1.4. In other words, here's my number line. Over here is a negative 8.7. I know I need the number to go up to negative 1.4. So what do I need to know? I need to know if it's going this way, I've got to add a positive in order to make it go right. If I got to add something to it. Now this one's a little trickier. And here I am at negative 8.7. I need to subtract something to get me up to a negative 1.4. Well, what could I possibly subtract to make this go right? How could I take something off? Taking away usually means I go left. How could I take something off to make it go right? Well, if you remember, subtracting a negative means it's one big plus, which is what we did over here. So guess what? D has to be negative. D has to be negative because we need it to go right, and the only way to get a subtraction problem to go right, to add a subtraction problem, is to make it a negative. It's kind of like taking off anchors, if you remember. Taking away anchors. Anchors are negative. So that'll help us wrap our heads around activity 1. It says for each situation, find 2 equations that could represent the situation from the bank of equations. Some aren't used. Explain what the variable v represents in this situation. And then it says determine the value of the variable that makes the equation true and explain your reasoning. So let's look at the first one. Between 6 a.m. and noon, the temperature rose 12 degrees Fahrenheit to 4 degrees. Between 6 a.m. and noon, the temperature rose. So the temperature was something. In this case, everything's going to be V. It rose. I mean, that's a plus sign. It rose 12 degrees. And now it is 4. So let's look. Do you see an equation like that up there? Yeah, here it is. Now, there's another equation apparently. And if you remember yesterday, we solved some of these. But in order to solve this, I need to add the inverse. I need to add the inverse. So in other words, I got to take what it is, if I'm trying to think of something that I add 12 to get to 4, it means I need to add the inverse. The inverse of 12 is a negative 12. It's essentially saying, well, I need 4. I need to take away 12 from 4. But remember, adding the opposite is the same as subtraction. And if you look, there's that problem right there. So now we need to solve it. What is 4 minus 12? Well, if you remember, they're different signs. So I do 12 minus 4, different signs, subtract, same signs, add, different signs, subtract. And I get 8. And I keep the larger one sign. The larger one is negative, so guess what? My answer is negative 8. Now it says explain. Well, we actually did the first dot here and the last one. We forgot to explain what the V meant. What did the V mean? What is that negative 8? Maybe solving it actually helps us, but V means, what is that V? V is by 6 a.m. and noon, the temperature rose to 4 degrees. V is the original or initial temperature. V is the initial or original temperature. All right, so we found the two equations. We determined the value, which is negative 8. Doesn't ever hurt to circle that. And we explained what V was the initial temperature. It was negative 8. Then it went up 12, and now it's 4. So let's look at B. It says at midnight the temperature was negative 6 degrees. By 4 a.m. the temperature had fallen to negative 16 degrees. At midnight the temperature was negative 6. It fell. We don't know how much it fell, but we know now that it's negative 16. Now let's look up there. Does anyone see a negative 6 minus V? The temperature was negative 6. By 4 a.m., the temperature had fallen. We don't know how much it fell. We just know it's 16. Does anyone see a negative 6 minus V equals a negative 16? No, me neither. Guess what? What it's saying is the other way we could rewrite this is we could say, instead of subtracting, it might be adding a negative. And they're not telling us V is negative, but if it says it had fallen, then V is probably a negative number, which is why this is the way they're writing it. So it's kind of saying it's the same thing, but a little trickier to see. These kind of are the same equations if we understand that, well, the value has to be negative. In this case, it has to be kind of the second equation because V should be negative. So technically the equation that I wrote, I should have wrote adding the opposite, and V will be negative. So first off, we could solve this, and in order to solve that, since it's an addition problem, adding the inverse, taking this negative 16 and adding the inverse of this, inverse of a negative 6. If I add 6 to it, I'll get that. If I'm at negative 16 and I go 6 to the right, technically they're different signs, so I subtract them, and I get 10. And the larger one is negative. So guess what? V equals a negative 10. Could have wrote that on that too. So what is that negative 10? Because we have to explain what it is. At midnight, the temperature was negative 6. By 4 a.m., it had fallen. Well, guess what? V is how much the temp fell. Or V is how much the temperature changed. It fell negative 10 degrees. It went down 10, which is why that adding, because if we used my equation, we would have gotten V equals 10, and 10 is technically not the equation. The answer to the equation. Technically, it should be negative 10. So we answered all three of those bullet points. So let's do letter C. The temperature is 0 degrees at midnight and dropping 3 degrees per hour. The temperature is negative 6 at a certain time. So it's 0 degrees, it's dropping 3 degrees. Normally I would write H for hours, but everything at once is V. So it's dropping 3 degrees per hour. It was Z. It's going down 3 times however many hours. Hint, hint, I just gave us what V stands for. And that's going to be a -6. In other words, how many hours does it take it to go from 0 to -6 if it's going down 3 degrees per hour? I should say too, guys, feel free to pause. You don't need me to tell you that, but I'll remind you to pause this. If obviously in a video I kind of speak a little bit faster with the understanding you can pause this whenever you want to get caught up on something, or rewind it if you need to hear something again. But continuing on, let's look up here. Does anyone see a 0 minus 3v equals a -6? Well, you might see this equation. Oh, we should have found the other equation, by the way. Is there a -16 plus 6 up there? Yeah, sorry. This went to the last problem. Jumped the gun. There's the other equation. That's how you solve the equation. But anyway, you don't see the 0 minus, because technically I don't have to write the 0. 0 minus 3v is the same as minus 3v, or a -3v. Now to solve this is a multiplying problem. The last two were adding problems. A multiplying problem, the way you solve it is you use the multiplicative inverse. A lot of you in your head can go, I know v equals 2, because -3 times 2 is -6, and that's great. But when the problems turn into fractions and decimals, we need to know the steps. And in order to solve this, I got to take the -6 and multiply it. Technically, I'm dividing it by -3, because a -6 divided by -3 is 2, which is the answer. But multiplying it by 1/3 is the same as dividing it by 3. But the multiplicative inverse, the inverse of 3, is 1/3. Well, the multiplicative inverse is. So it's the same as dividing by 3, but in this case, you're going to notice up there, nowhere does it say -6 divided by 3, but you will see a -6 times a -1/3. It's written in a different order. They wrote -1/3 times a -6, but same difference. So we already know that that equals 6/3, which is 2. That equals V. And what does that V mean? What does V stand for? Well, if you remember what I said earlier, -3, it's dropping 3 degrees per hour. The temperature is -6. V in this case is the number of hours it takes to fall down. You need me to unlock that? Sorry. All right. Letter D. The temperature is 0 degrees at midnight and dropping 3 degrees per hour. The temperature is 9 degrees at a certain time. Sounds like the exact same problem. It's dropping 3 degrees times the number of hours, and now it's 9 degrees. So the last one we said, well, it was 0, and after 2 hours it's now at -6. Sounds like the temperature's definitely got to be above 9 degrees if it's dropping, and now it's 9. So first off, we should have 1, 2, 3, 4, 5, 6. Now we got to find another equation. And you'll notice right there, that's that one that we just wrote. So everything's the same. I'm just going to draw an arrow, because V is the same. It's the number of hours, the temperatures, I guess the number of hours, the temp, not just number of hours, the temperature is changing. This is the same problem, so I'm just going to draw an arrow down there. V stands for the same thing. Now, in order to solve this, Same exact thing. We're going to take this 9 this time and times it by a negative 1/3. The inverse, the multiplicative inverse, 3v means 3 times v. So what's the inverse of 3? It's 1/3, and we'll get a negative 9/3, which is, by the way, a negative 3. The temperature is 0 degrees and is dropping 3 degrees per hour. The temperature is 9 degrees at a certain time. Let's see if we can make sense of what V means. But first off, let's find 9 times a negative third, or negative third times 9. There it is. So we've got that equation. And so what does negative 3 mean? How can we have negative time for this equation? Well, it just means if it was 0 and it was 9 degrees at a certain time, that means 3 hours ago. That means not 3 hours from now. It means 3 hours ago it was 0. And now it is, or 3 hours ago it was 9, I'm sorry. And now it's 0. Okay. Moving right along. The temperature at 9 p.m. is 1/3 the temperature at midnight. The temperature is 1/3 the temperature. The temperature at 9 p.m. is 1/3 the temperature at midnight. Are we supposed to use the temperature at 9 p.m. is 1/3 the temperature at midnight? In other words, you can clearly see it. There's 9 p.m. and midnight here. I'm having to think about this because right now I see 1/3 of something, V, or times 1/3, or 1/3 times V. But there's no other numbers, and usually we need another number for equation or another. And the only other thing I can see here is if it was 9 p.m. at midnight, that means 3 hours has passed. The temperature at 9 p.m. is 1/3 the temperature at midnight. Let's look up here. It's 1/3 the temperature. Makes me think that something's missing here. What's going on here? Because technically we don't have enough. The temperature at 9 p.m. is 1/3 the temperature at midnight. I think it should be, if it said the temperature at midnight is blank, well, we'd have enough. But I don't know if there's enough. I think, like, every once in a while this curriculum has a typo, or I'm just not thinking clearly, which definitely is very possible. And maybe I'm missing something. But if you can think, is there another number I'm missing? I think there might need to be like this. There needs to be it should say something about a -4 somewhere, being the temperature is now -4, and maybe that would be the equation, because I see its inverse right here as well. But I think it's missing some information. So I'm not 100% sure what's going on right now. So that's good enough for now. By all means, if yours says something different, let me know. Let's look at activity 2. Just kidding. We're going to skip that one, although feel free to look at that if you have extra time another time. But we're going to move on to activity 3 because it's just more practice of what we're doing. And what we're doing is ridiculously important for all of 8th grade math, the rest of this year, and just about all of high school math. Let's look at activity 3, equations tell a story. Your teacher's going to assign you one of these, and by the way, I'm not. We're just going to go ahead and knock some of them out. And then we'll definitely probably do some of this more too next week when we get to it. But anyway, it says create a visual display. We're just going to just go ahead and squeeze in our work on it. It says we're going to write an equation. What your variable means what does V mean. We get to make up our letter, though. I like making up letters that is more relative to the story. If it's T, if it's time, I like to use T. If it's distance, I like to use D instead of V or Y or X. You'll always see Y or X. But anyway, how the operations in the equation represent the relationship. So if we see a plus sign, we're saying it's going up. If we see a minus sign or a negative sign, it means something's going down. If we see a multiply sign, it means something's repeating itself a certain number of times, and so forth. And then how to use inverses. So again, if it says something plus something, in order to solve that, we add the opposite. We subtract. If something says multiply, we multiply by the inverse. So if it said times 3, we're going to times it by a third. If it says times a third, well, the inverse of a third is 3. We times it by 3, and then we'll solve it. So I don't know if we'll have time for all of this, but we'll see what we can do. It says, as a 7/4 inch candle burns down, its height decreases 3/4 of an inch each hour. How many hours does it take for the candle to burn completely? So step 1 is to write an equation. So hopefully we're seeing something, and your equation could look something like this. Well, I've got a candle that is burning 3/4 of an inch per hour. Our first instinct is maybe to saying, well, 7 1/4 minus something, and that's fine. We could write it the way our instinct's saying. We got 7 1/4, and we're taking off 3/4 of an inch for a certain number of hours. That's kind of what the equation is, but I'm going to rewrite this a different way. It's going to mean the identical thing, but technically when we write it like this, it makes it easier to solve. A candle is decreasing 3/4 of an inch per hour. I guess we should maybe make this negative, but we'll see. How many hours? Well, 3/4 of an inch times, we'll use H for hours. If it's going 3/4 of an inch times the number of hours, is it 1 hour? But regardless, when will it take for, now our initial instinct is, when will it take that 7 1/4, 7 1/4, when will it take away? But if we solve this, you notice I have a negative answer, and I don't really necessarily need negative answers, but essentially what we're saying is, how long until we get rid of that 7 1/4, which means kind of essentially writing that as a negative. If we didn't, we'd still get the right answer. We'd have a negative answer, which just kind of would say that this many hours ago that whole candle was there. It's a minor technicality, but at least we'll get a positive answer this way. So how would I solve this? Well, it's a multiplying problem. I got a negative 3/4 times who knows how many hours. But after 1 hour, that'd be taking away 3/4 of an inch. 2 hours would be 6/4. Well, in order to solve this, it's a multiplication problem. I need to multiply by its inverse. I need to take this negative 7 1/4. And I guess we should go ahead and quickly answer the next question says what your variable and each term in the equation represent. We should say, let's answer all. Going down 3/4 of an inch every hour. Again, this is all supposed to be done on a poster, but we're squeezing it in where we can. This is the number of hours it's burning, or number of hours it's melting. And this is the current H-E-I. It's the current height, right? And I guess we could also say, point an arrow, that means negative. I guess that's the current height or the amount it needs to go down. This also is, maybe we should say the amount it needs to go down because it's a negative answer. The amount it needs to go down, maybe that's a better answer since it's negative, because the current height, saying the current height is negative doesn't really make sense. The amount it needs to go down, it needs to go down 7 1/4 because we're waiting for it to be gone. But in order to solve this, we need to multiply that negative 7 1/4 by the inverse, the multiplicative inverse of negative 3/4. And if I took 3/4, the inverse of that is 3/4, upside down. It's a negative 4/3. Because guess what? 3/4 times 4/3 is 12/12, and that's equal to 1, and that is what we want. We want the multiplicative inverse. Now, there's a lot going on here. How would I solve this? First off, I got to change this into an improper fraction. And if you remember, I can change, I have the buying rule, means how many fourths is 7 1/4? Well, 7 is 28 fourths. 28 fourths, meaning 28 divided by 4 is 7. 28 fourths, 7 is 28 fourths. 7 times 4, 28 fourths plus another fourth is 29 fourths. 29 fourths times 4/3. And now I need to get out a calculator. But technically I can do this in my head. 29 fourths is just like 30 fourths, which is 12 with a 0. That's 120, but that's 4 too much. So that's actually 116. Whether or not you knew that, who cares? You get out a calculator and do 29 times 4. It's 116. So I have 116 twelfths. And I do know that I do have a calculator on my hand. Not on my hand, I mean on my phone. So I'm going to do 116 divided by 12. And I get 9. And 8 with the remainder of 3. 9 and 8 twelfths, or 9 1/3. Sorry, 2/3. 8 twelfths is 2/3. Those are hours. Let's not write the H, so it looks like it's... So let's see, how many hours does it take? It takes 9 hours. 9 and 8 twelfths is 2/3 of an hour, which is 40 minutes. But we could leave it just like that, or simplify it to 9 2/3, or 9.6 repeating if you used a calculator, which is fine. But after all of that, we have now finally answered the question. And that makes sense. If it's 7 inches, roughly, and it's not quite burning an inch an hour, well, if it was an inch, that'd be 7 hours. But it's less than that, so it's going to be slightly more than 7 hours, and it'll be 9 hours. So, wow, a whole lot going on there. And that's just we'll probably do all of these. But let's look at letter B. This is a ridiculously cool problem. This is, believe it or not, similar to what we have done already. Back in when we did percentages and or percentage increases and decreases. We started, if you remember, with fraction increases, just increases and decreases. But let's look at this. On Monday, 1/9 of the students, of the enrolled students in school were absent. That sounds like a lot, but if you think about what we were just doing, we had a ton of people absent, so it's possible. there were 4,512 students present. That's a huge school. There are some schools in Phoenix, Arizona that have that many kids. But maybe they're talking about a small college of some sort. How many students are enrolled at the school? On Monday, 1/9 of the students, of the enrolled students in the school, were absent. There were 4,512 students present. All right, we got to write an equation for this. And there's lots of ways to go about this, but if I took the 4,000, we're starting with, well, let's start with this, with the number of students, right? If we took off 1/9 of the students, that's definitely not a very good, and I'm just using X because my S's will look like phi's for students. If we started with students and we got rid of 1/9 of the students, we'd be left with the students that are there. So there's our equation. We're done with the equation. We do need to label X, by the way, then is what? We got to say what our equation is. X, that's an arrow, by the way. That's the number of, whoa. Don't need that. How do I get back to that? Shenanigans. I love technology. How do I go back? Not that one, not that one, how about that one? Yes, but now I gotta scroll. Sorry about that. I accidentally clicked too close to something I shouldn't have. Yippee. Hope you're getting nauseous. And we're getting closer. Look at all this wonderful work. Cha-ching. Stop. On Monday, so X is the, back to this, what does X stand for? X is the total students, right? Or total students enrolled. Got it? The minus 1/9, that is the absent kids, right? And this is the current students, right? Now I'm going to borrow some space down here. But either way, now in order to solve this, first off, we've got to take X and take off 1/9 of an X. By the way, that's kind of like saying what's 1 minus a ninth? X, there's one X right there. That X, there's one. If I take off 1/9 of that, or if I had a chocolate bar and I got rid of 1/9 of it, what's left? Well, this kind of goes back to like those percentage problems. If I took 25% off, that means 75% is still there. So if I went to a store and I saw 25% off, that means I still have to pay for 75% of it. So if I took the price and times it by 75% or 0.75, I would get that. It's kind of like this. If I took X, I could have originally said if 1/9 of the students were absent, that still means that 8/9 of the students, the total number of students, are still there. So I could have wrote my equation like that. 8/9. Now, in order to solve that, guess what? It's a multiplying problem. This 8/9 times X, that's a multiplying problem. 8/9 times something gives me 4,512. Well, in order to solve that, I can take 4,512 and divide it by 8/9. That's the same as taking 4,512. Oops. And multiplying it, dividing it by 8/9. If I divide by 8/9, which is correct, I have to do keep change flip, which is essentially multiplying by the inverse. The inverse of 8/9 is 9/8. It's just a shortcut for dividing by 8/9. I personally like to say it's dividing by 8/9. This book kind of teaches multiplying by the inverse, which is the same difference. It kind of is better because it's a shortcut. But anytime you divide by fractions, hopefully your brain is automatically thinking the short stuff. So now I got to solve that, which we're going to have some big numbers, but I'm going to do 4,512 times 9, and then I'm going to divide it by 8. 4,512 times 9. That equals a big number. That equals 40,608. We're going to divide that by 8. Divide that by 8. And guess what? We get 5,076. That makes sense because there should be more students. Our answer should be bigger than the current number of students that are there because a lot of them are sick. So there was 5,000 kids at the school. If they're all there, miracle. But if 1/9 of them are gone, then that means 4,512 are left. And phew. All right. I'm going to leave it up. I want you guys to do letter C on your own. And then when you're done with that, because I think you could do that. I don't think, and I'm not even going to show you how to, I mean, I should show you how to answer, but I want you to try it. So at least then when I see it and give you credit for doing your work, I can say, oh, you tried it. And we can go over that hopefully maybe next week. But that is lesson 16. And should have done lesson 15 practice problems last night. And you can do here was last night's homework. Hopefully in order to solve this from last night, you should have gone, you got to take that 6 and multiply it by the inverse. You got to take this and go to 4.5, and you got to add 8 to it. Hopefully on 12, you multiplied it by the inverse. Hopefully you took this negative 12 and multiplied it by its negative 3, the inverse of that, the inverse of that, the additive inverse of that, the multiplicative inverse of that. Oops, I skipped letter C. I got to take that negative 3, and the additive inverse of a half is adding a negative half or subtracting a half. So that's how you solved all those. Problem 2, problem 3, I'm going to leave it up to that. And so your homework is lesson 16 to match each equation to one of these situations. So A, B, C, D, all these equations belong to one of those. I'll leave it up to you to try to think this through. Problem 2, pretty straightforward. Starting at noon, the temperature dropped at a steady rate of 0.8 degrees Celsius every hour. So it was going down 0.8 degrees. So after 1 hour is 0.8. After 2 hours, it's 1.6. After 3 hours, it'd be 2.4 and so forth. It says for these situations, write and solve an equation and describe what your variable. How many hours did it take for the temperature decrease? Well, your variable is going to be H for that, and that would be the number of hours. It almost tells you what your variable is going to do or what it is. Problem B, if the temperature at their 4.4 degree drop was negative 2.5 degrees, what was the temperature at noon? So your variable is pretty much kind of what the question is. But other than that, guys, I'll leave the rest up to you. I think you can figure out the rest. Problem 3, kudos to anyone who wants it. That one, it's awesome problem, and we can do it. Kieran mixes 3/4 of a cup of raisins, 1 cup of peanuts, 1/2 cup of chocolate chips. How much of each ingredient would he need to make 10 cups of the trail mix. You kind of got to figure out, well, 3/4 plus 1 plus a half. Oops, that should be a plus sign. If we notice, first off, and figure out, well, what's one batch of this? Well, 3/4 plus a half, that's kind of like saying 3/4 plus 2/4. Because a half is 2/4, that's 5/4, which is equal to 1 1/4. And if I add 1 to that, that's 2 1/4. So one batch is 2 1/4, which is really kind of annoying for this problem. 3/4. So that's 2 1/4. How many batches would we need times what to get 10 cups? And then you got to take that x and multiply each one of those 3/4. In other words, we're trying to figure the constant of proportionality. We'd have to take 3/4 times that number, 1 times that number, and a half times that number. So a whole lot going on here, but go ahead and take the rest of that problem off, unless you want to finish it. Kudos to you. It's pretty ridiculously spicy 7th grade problem, but that's about all we have time for, guys. I'll leave the rest up to you guys. Finish lesson 16 practice problems. Have a great weekend or rest of your day, depending on when you watch this. As usual, email me if you have any questions or concerns, and as usual, make sure if you did not like this video, you click that like and subscribe button. All right, peace.